In the last module, we focused on how a firm determines its production function. And now we're going to turn from that and extend into how a firm determines its costs of production. Because remember, we said that in order to maximize its profit, a firm has to subtract its total cost from its total revenue. And so here we are going to figure out how a firm determines its actual costs of production. And this will be important. And remember, when we talk about firm costs, we are always talking about economic costs, not accounting costs. So in this module, I'm going to begin by describing the various types of costs a firm faces, including fixed cost, variable cost, and total cost. And from there, I'll explain how a firm's costs generate marginal cost curves and average cost curves. So we're going to begin by talking about short-run production costs. In the next module, we'll look at how a firm determines its production costs in the long run. Now, to review, if you remember, when we talked about the short run, a quick reminder of the definition here. Short run is not a set specific amount of time. Remember, it's not 2 days, 3 months. The short run is defined as a period of time which at least one resource is fixed. Typically, this would be the size of the plant. And the plant capacity, which would be capital for the firm. It's possible that other resources such as raw materials and labor could be fixed, but oftentimes it's capital that's fixed. Because if you think about it, if a firm is producing in a given space and its factory, it takes a while to be able to expand it or build a new one. And so in a certain period of time, that is not changeable. In the long run, which we'll focus on in the next module, all resources are variable. There are no fixed resources, and the plant capacity and size is changeable. You can expand the size of your plant, you can build a new plant, but it takes time to be able to do that. So today, in this module, we're only examining short-run costs. Now we're going to look at some of the types of costs that we're going to be focusing on. And each of these is going to be explained throughout the module. I'm just introducing them here. When it comes to total costs, we're going to look at total fixed costs, total variable costs, and total costs. And you can see those listed here along with their common abbreviations. And then we're going to look at per unit costs. Per unit costs are costs for one unit of a good or service, rather than the total cost for producing all of the goods and services. And these can be divided up into average fixed costs, average variable costs, average total costs, and marginal cost. So let's begin with some definitions before we break these down and determine how the firms determine their costs. When we talk about fixed costs, these are costs for fixed resources that do not change with the amount produced. In other words, these are costs that a business has to pay for even if they produce nothing. And if they increase the quantity that they produce, the cost of these items remains the same. They don't change. So a firm must always pay these costs. So think about rent that they're paying on a building, or insurance for their firm, salaries they pay to their managers. If they produce nothing, they still have to pay all of these costs. And if they increase the amount they produce, these costs do not change. They stay the same. That's why we say they're fixed. Now, if we spread those costs amongst the quantity of the good or service we're producing, then we get the average fixed cost per unit. When it comes to variable costs, these are costs that do change with the quantity of a good that is produced. So if we produce more of something, we buy more of these items and we pay more. If we produce less of something, we buy less of them. So examples would be raw materials that go into the good or service that we're producing. Labor, we may have to hire more workers to produce something. Electricity, if we're producing more, we use more electricity, and we have to pay more for it. So these are costs that change with the quantity that we produce. If we produce more, these costs go up. If we produce less, these costs go down. And of course, if we spread these costs amongst all of the units that we're producing, then we get average variable costs, which is variable costs divided by the quantity. Moving on, if we look at both of these costs together, if a firm totals its fixed costs and its variable costs, it will come up with its total cost of production. And then if we want to know, well, what is the average cost to produce a good that we're producing, that would be average total cost, and that would be our total cost divided by the quantity of what we're producing. We can also look at the marginal cost. Remember, marginal analysis is very important in economics. It helps us understand all kinds of concepts and how decisions are made. So once again, here we talk about marginal analysis by looking at marginal cost. And the marginal cost, remember, marginal always means additional. So the marginal cost of producing something is the additional cost of an additional output. So if we produce one more unit of a good or service, how much more does it cost us to produce that than what it cost us to produce before? So if the production of two more output increases total cost from 100 to 120, the marginal cost is 10. Why? Because our total cost of production by producing two more went up by $20, but if we want the cost per unit, we have to divide 20 by those two additional units, and 20 divided by 2 is 10. So that gives us $10. So the marginal cost is the change in total cost divided by the change in quantity. And this is going to be a very important concept to understand as well. Again, this slide just reviews those types of costs that we just looked at. Fixed cost is a cost that does not depend on the quantity of output produced. And so a fixed cost is the cost of that fixed input, whatever it is. A variable cost is a cost that depends on the quantity of output produced. And so that variable cost is going to be the cost of the variable input. Therefore, the total cost of producing a given quantity of output will be the sum of the fixed cost and the variable cost of producing that quantity of output. If we abbreviate it, and in economics we commonly use abbreviations in these formulas, and so you should be familiar with what all these abbreviations are. TC always stands for total cost, FC stands for fixed cost, and VC is variable cost. And so total cost is the sum of our fixed cost plus our variable cost. And then we can graph that to produce what we call a total cost curve, and we will see that the total cost curve becomes steeper as more output is produced because of diminishing marginal returns. So let's look at an example here. Let's go back to Eli and Max and their lemonade stand. Suppose that Eli and Max have done an exhaustive study on the costs of producing cups of lemonade, and they find that they have to pay $50 every day to the city for the right to sell lemonade on the sidewalk. This cost goes in the fixed cost column because it doesn't matter if they sell 50 cups of lemonade or no cups of lemonade, they still have to pay $50 to the city. So that cost remains fixed no matter how many units they produce. But they also have to pay $25 for every employee that they hire. And we'll assume now that, to keep it simple, this is their only variable input. So in the variable cost column, you can see that every time they hire a worker, their variable cost goes up by $25. So it's the variable cost of hiring a worker, $25, multiplied by the number of workers that we hire. Now, what do we see if we graph these cost curves? In the graph below, or in this slide, we can see that fixed cost is a horizontal line. Why? Because it doesn't change. No matter how many units we produce, it always remains at $50. Even if 0 cups of lemonade are produced, it is still $50. But the variable cost curve, if you see that curve is rising. Why? Because as we produce more, we have to pay more for our variable costs. And so variable cost is rising, and it rises more quickly at higher levels of output. Why? Because of diminishing marginal returns. So it's flatter in the beginning when we're getting more output per worker, but as we hire more workers, the output per worker goes down, and we still pay them the same amount, so the variable cost per unit actually rises at a steeper rate. The total cost curve, notice, has the same shape as the variable cost curve. Why? Because it is simply the variable cost plus a constant level of fixed cost. So fixed cost is the same, and then you add it to variable cost, which is rising, the total cost curve is going to have the same shape, and that means that the vertical distance between the total cost curve and the variable cost curve will always be the fixed cost of $50. Here we can look at another example. George and Martha on their farm, and they're producing bushels of wheat. you can see that here they are maybe paying a cost to rent their land. Maybe they have 20 acres of land and they're renting it for $400. So whether they produce nothing or a large quantity of wheat, they have to pay $400. So in the fixed cost column, you see $400 all the way down. But they also have to hire workers. And each time they hire a worker, they pay them $200. So every time we hire an additional worker, it's an additional $200, and you see that in the variable cost column. So the variable cost is rising. And then you add the variable cost and the fixed cost together, and that gives you the total cost, which is in the last column. So you can see that when we graph these as different points on the curve, quantity of wheat is graphed on the x-axis, and the cost of producing that wheat is graphed on the y-axis. And then we plot those different points, and we can see that how much it costs us to produce different quantities of wheat. And in the beginning, the curve is flatter, but as we produce more wheat, the total cost curve gets steeper, and that's again because of diminishing marginal returns to an output. We hire more workers, and each worker produces fewer bushels of wheat than the worker before because of diminishing marginal returns. So the production function gives us cost functions and total cost curves. And some very interesting and useful concepts are derived from the total cost functions. Two key concepts that we're going to look at are marginal cost and average cost. As in the case of marginal product, marginal cost is equal to the rise divided by the run, which is the slope of the curve, the increase in total cost divided by the increase in the quantity of output, each measured on a different axis. And that's the slope of the curve. And so the marginal product will always be the marginal cost rather will always be the slope of the curve, just like it was with marginal product. So marginal cost is defined as the change in total cost divided by the change in quantity of output, or MC equals delta TC divided by delta Q. And it's the change in total cost generated by one additional unit of output. In other words, by how much does our total cost go up when we produce one more unit? So we have seen marginal cost before, and if you remember that total cost or variable cost is measured on the vertical axis and output is on the horizontal axis, remember marginal product was shown to be the slope of the total product, and as I said, the same is true here, marginal cost being the slope of the total cost or variable cost. Now, the table below shows the marginal cost for Max and Eli's lemonade stand. And notice that the change in output is 8 units. For an example where output changes only 1 unit at a time, we'll look at this in another example. Now, why does marginal cost initially decline, but eventually increases as more output is produced? This is because of the diminishing returns to labor in the production function, which causes this to occur. As output increases, the marginal product of the variable input, in this case labor, declines. That means each worker produces less or fewer cups of lemonade than the worker before them. This implies that more and more labor must be used to produce each additional unit of output. And since each unit of the labor must be paid for, the additional cost per additional unit of output also rises. And when we graph it, we see that in the marginal cost curve. It declines in the beginning because when we have very few workers hired, they specialize and we get increasing marginal returns, but only for a very short period of time. And after that, diminishing marginal returns set in, slowly at first, but then as we hire more workers, those diminishing marginal returns rise rather quickly, leading to a steeper marginal cost curve. Mr. Clifford has produced a video on this called Costs of Production. So if you visit the ACDC Econ website, which you're always welcome to do, and look for ACDC Econ, and then under Microeconomics Videos, search for Costs of Production, and you can watch this video there. This activity here on cost of production and cost curves we will do in class. This is another graph which shows Selena's gourmet sales, and again looks very similar to some of the charts that we've looked at previously. If you want to pause the video and go over this might help you to understand the difference between it before. But you see here she has fixed cost of $108. Her variable cost goes up by $12 at a time when she hires more workers, and you can see the total cost plus equals fixed cost plus variable cost, and the marginal cost to produce a case of salsa is the change in the total cost divided by the change in the quantity that is produced. And so you do that, and then you can see the increase there. So if you want to pause the video and examine this to help you understand it further, if you need that time, feel free to do so. So if we graph Selena's gourmet salsas, we can see her total cost curve in panel A and her marginal cost curve in panel B. Her total cost curve, as we see, is continuously rising because total cost rises as you produce more, but it rises slowly in the beginning. So the second case of salsa increases her total cost by only $36, but when she produces her 8th case of salsa, her total cost goes up by a whopping $180. Again, that's because of diminishing marginal returns. Her marginal cost of production, you can see, is also constantly rising because as she produces more salsa, the additional cost of producing each case of salsa is higher than the case before, and so marginal cost is continuously rising. Now, the question is, well, why is the marginal cost curve upward sloping? Okay, and as I've alluded to prior to this, because there are diminishing returns to inputs in this example, as output increases, the marginal product of the variable input declines. And this implies that more and more of the variable input must be used to produce each additional unit of output, as the amount of output already produced rises. And since each unit of the variable input has to be paid for, and it's producing less, the marginal cost increases. Another important concept to understand is average cost of production. Average total cost is the total cost divided by the level of output, sometimes called average cost, unit cost, or per unit cost. So the equation for that is ATC equals TC divided by Q. We can isolate the variable and fixed costs from the total and compute per unit variable, average variable, and per unit fixed or average fixed costs as well. So average fixed cost is going to be FC divided by Q, or fixed cost divided by the quantity of output. And you will see that when we graph the average total cost curve, it will be a U-shaped average total cost curve, which will fall at very low levels of output and then rise at higher levels of output. We can also compute the average variable cost, which is the variable cost per unit of output, and that is AVC, which is VC divided by Q, or the variable cost divided by the quantity of output that we produced. So because total cost equals variable cost plus fixed cost, we can rewrite the equation for ATC and say ATC is equal to the variable cost plus the fixed cost divided by the quantity, which is equal to the average variable cost plus the average fixed cost. So now we can complete the table by filling in the average total cost, average variable cost, and average fixed cost columns. What do we see in this chart? We see that average fixed cost declines as more output is produced. And this makes sense since the fixed cost is constant. But we are dividing by more and more cups of lemonade. The owners must pay $50 for the sidewalk space, so when we divide by larger cups of lemonade, this fixed cost is spread out over more output. The average total cost curve has a U shape, At first it declines, but eventually rises as more output is produced. Why? Well, average total cost has a U-shape because when more output is produced, two effects are happening. One effect, the spreading effect, lowers average total cost as more output is produced. The other effect, the diminishing returns effect, causes average total cost to rise with more output. So here we can fill out the chart and we can calculate average total cost for 6 units, average fixed cost of 2 units, average variable cost of 4 units, average total cost of 1 unit, average variable cost of 5 units, average fixed cost of 5 units, and average total cost of 5 units. And when we do that, notice that the AVC plus the AFC equals the average total cost. For 5 units, okay, the average variable cost is $12 plus an average fixed cost of $2, and that equals an average total cost of $14. Now, you can pause the video and figure out, is this also true for 4 units of production? Notice here, if you look at this chart, that the average variable cost plus the average fixed cost equals the average total cost. So just as total cost equals fixed cost plus variable cost, average total cost is equal to average variable cost plus average fixed cost. And then when we graph these costs, we come up with our different cost curves. You can see that the average fixed cost is declining quickly at first and then at a slower rate as the fixed cost is divided by more and more units. The marginal cost curve is like a Nike swoosh, declining in the beginning because of increasing marginal returns initially in the beginning because of specialization of labor, but then increasing after that because of diminishing marginal returns to labor. Average variable cost is declining in the beginning because of those increasing marginal returns, but then increasing because of diminishing marginal returns. And average total cost, we said, is like a U-shape, declining in the beginning as the spreading effect of average fixed cost is greater in the beginning, but then increasing after that as the average variable costs are greater when they're increasing than the diminishing effect of average fixed cost. So why do the curves look like they do? I alluded before to the spreading effect and the diminishing returns effect. Well, when we increase our output of production, this has two opposing effects on average total cost, and this explains the U-shape of the average total cost curve. The spreading effect says that the larger the output, the greater the quantity of output over which fixed cost is spread, leading to lower average fixed cost. The diminishing returns effect says that the larger the output, the greater the amount of variable input required to produce additional units, leading to higher average variable cost. So at low levels of output, the spreading effect is more powerful than the diminishing returns effect, because even small increases in output cause large decreases in average fixed cost, thus pulling down the ATC. But as output rises and diminishing returns become a bigger issue than the spreading effect, that pulls the upward pull of average variable cost becomes stronger than the spreading effect, and it begins to pull ATC upward. And so what we saw in the graph before was average total cost, average fixed cost, average fixed cost, and MC. And it's also the case that the marginal cost curve intersects the U-shaped ATC and AVC at their respective minimum points. And if you look at that on the previous graph, you'll see that the marginal cost curve intersects the average variable cost curve at its minimum point. Why? Because before that point, marginal cost is pulling, the increasing returns effect is pulling the average variable cost down. But then after that, it's pulling it up. The same thing with average total cost. When it's below average total cost, it's pulling the average down, But when it's above average total cost, it's pulling the average up. So it intersects the marginal cost curve intersects the average variable cost curve and the average total cost curve at their respective minimum points. Again, here you see Selena's gourmet salsas, and you can see, if you pause the video, you can see her total cost, her average total cost, her average fixed cost, and her average variable cost for producing cases of salsa. And then if we graph those costs here, you can see that her minimum average total cost is at an output of 3 units by looking at the minimum point of her average total cost curve. So the marginal cost is related to both AVC and ATC. But let's focus on just the relationship with ATC. The average total cost will fall as long as marginal cost is less than average total cost. As soon as the marginal cost rises, so that marginal cost is greater than average total cost, the average total cost will begin to rise. If the marginal cost of the next unit is equal to the current average total cost will not change. And if you think about it, this makes sense. So think about your GPA, think about your grade point average, with your total GPA reflecting your average total performance over your years in school. And your next grade that gets added to your average is the marginal performance this semester. So if you have an overall GPA of a 3.0, and this semester you earn a 4.0, your average will rise. If your GPA is 3.0 and this semester you earn a 3.0, your overall average will stay the same. And if your GPA is 3.0 and this semester you earn a 2.0, your average will fall. So when you add a marginal grade that is less than the average, it pulls the average down. When you add a marginal grade that is greater than the average, it pulls the average up. And that's what's happening with the average total cost curve with respect to marginal cost. So marginal cost is upward sloping due to diminishing returns. Average variable cost also is upward sloping, but is flatter than the marginal cost curve. Average fixed cost is downward sloping because of the spreading effect, and the marginal cost curve intersects the average total cost curve from below, crossing it at its lowest point. And this last point is important because that's going to mean something for the firm in terms of its cost of production. Here's another video that you can watch produced by Mr. Clifford. So if you go to the ACDC Econ website, you can watch the cost curves video. This is an activity that we'll do in class on firm costs. This graph here shows the data from the slide before, where we graph Selena's gourmet salsas. We see her marginal cost curve is rising, intersecting the average total cost curve at its minimum, because when marginal cost is below average total cost and average variable cost, it's pulling those cost curves down. But as soon as it goes above the average variable cost curve and the average total cost curve, it pulls those curves up. Why? Because it's greater than the average. But you can see her marginal cost curve intersects the average total cost curve at the minimum of average total cost. Average variable cost is rising, average fixed cost is falling as it's spread over more and more units. So here you see those 4 cost curves graphed together. So the minimum cost output is the quantity of output at which average total cost is the lowest. That's the bottom of the U-shaped average total cost curve. At the minimum cost output, average total cost is equal to the marginal cost. At output less than the minimum cost output, marginal cost is less than average total cost, and average total cost will be falling. At an output greater than the minimum cost output, marginal cost will be greater than average total cost, and average total cost will be rising. So, where marginal cost is equal to average total cost will always be at the minimum of the average total cost curve. And here we see the relationship between the average total cost and the marginal cost curve. You can see Again, if marginal cost is below average total cost is falling. If marginal cost is above average total cost is rising. And so marginal cost is equal to average total cost at the minimum of the average total cost curve, which is U-shaped because of this. So, does the marginal cost curve always slope upward? Well, a quick look at the marginal cost curve for the lemonade stand would show that initially the marginal cost of producing lemonade falls. So in practice, marginal cost curves often slope downward as a firm increases its production from zero up to some very low level of output. This initial downward slope occurs because a firm that employs only a few workers often cannot reap the benefits of specialization of labor. This specialization can lead to increasing returns at first, and then to a downward sloping marginal cost curve. But once there are enough workers to permit specialization, diminishing returns set in. So when we look at the lemonade stand, it shows that initially the marginal cost of producing lemonade falls. This period of falling marginal cost doesn't last long, and soon marginal cost rises for the rest of the range of production. Marginal cost can fall initially, as I said, due to the specialization of labor in the production function. Before diminishing returns occur, imagine workers dividing the tasks according to their talents. Eli is great with customers, so he sells the lemonade, greets the customers, collects money, and makes change. Max is extremely fast in the kitchen, squeezing lemons, mixing with sugar, and flawlessly pouring perfect cups. With this kind of specialization, marginal product rises at first. But when more units of labor are hired, diminishing returns are experienced as they get in each other's way and can't divide up the work so easily, and maybe don't work so well, and soon marginal cost rises as a result of that. Here's another video that you can watch from Mr. Clifford at the ACDC Econ website. It's called Marginal Cost and Average Total Cost. This activity on marginal cost and average total cost we'll do in class. This again shows you some more realistic cost curves, showing increasing specialization that I just talked about, which leads to lower marginal cost in the beginning, but then diminishing returns setting in once the benefits from specialization are exhausted and marginal cost rises. So the marginal cost curve often looks like a Nike swoosh. The average total cost curve is U-shaped, and average variable cost looks similar. And here we can see some links between productivity and cost. Okay? When we look at the marginal product of labor curve and the average product of labor, we can see marginal product and average product of labor rise in the beginning. Why? Because of specialization. And that leads to the Nike swoosh in the marginal cost curve and the U-shape of the average variable cost curve, because you get specialization in the beginning. So when you hire just a few workers, they can all specialize in their tasks and increase their marginal product and their average product. But then diminishing marginal returns set in, and after that, marginal cost and average variable cost will begin to rise. Again, here's another graph that shows average total cost and average variable cost get closer to each other and closer, but they never actually touch each other. And the average fixed cost, of course, will be the distance between the average fixed cost and the x-axis. Here you can pause the video and attempt to calculate total cost, variable cost, and fixed cost of the fixed unit. It would be the area of these different shades. So if you look at average variable cost of the fifth unit, you would go to the fifth unit up to the average fixed cost curve and draw a line over, and the area of that rectangle would be the average fixed cost of that unit. If you go from that point on the average fixed cost up to the average variable cost curve and over, the area of that square would be the average variable cost. If you go further up to the average total cost curve from the average variable cost curve and over, you take the area of that rectangle, and that's going to be the average total cost. So you can take the area of these three different rectangles at the fifth unit and calculate what the total cost, the variable cost, and the fixed cost of the fifth unit would actually be. And see if you can do that now. Here you see more total cost curves. And again, we've talked about this before, but if you want to pause the video, you can stop and look at this again if you need more time looking at the fixed cost curve, the variable cost curve, and the total cost curve. We'll do more practice with cost curves in class. And this practice slide here, I'm going to pause the video here because everything on the remainder of this slideshow is practice, and we will do that in class. So this is going to conclude our look at Module 55 on costs of production.